Hey there, my name is Alejandro and welcome back for day 43 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for August 28th, 2024, and let's get straight into it. Okay, today we get a LeetCode medium, problem 1905, count sub-islands. You are given two n by n binary matrices, grid 1 and grid 2, okay, two grids, containing only zeros representing waters and ones representing land. Okay, one of these types of problems, like number of islands. Okay. An island is a group of ones connected four directionally, horizontal or vertical. Okay, yeah, sure. Any cells outside the grid are considered water cells. Okay, sure. An island in grid 2 is considered a sub-island if there is an island in grid 1 that contains all cells that make up this island in grid 2. Okay. So an island in grid 2 is considered a sub-island if there's an island in grid 1 that contains all the cells that make up this island in grid 2. Sure. Return the number of islands in grid 2 that are considered sub-islands. This is actually simple. Okay, the first idea that comes to mind is, first of all, we can write number of islands, right? But if we write something like number of islands for grid 2, we're not just going to blindly add 1 to the number of islands that we find for every island that we find. We're instead only going to add 1 whenever we find a sub-island, right? And the way it's going to happen is that, like, okay, whenever we find a 1, we're going to populate, we're going to essentially, okay, we'll change that island to be waters, right? So change every 1 to be a 0, right? And at any point, if in traversing the island, we see that the same index is a 0 in the other grid, then we know it's not a sub-island. Otherwise, if we never saw a 1 in our grid 2 island that was a 0 in the grid 1 island, or grid 1 specifically, then we know it must have been a sub-island. I think something like that would work, right? Okay, so something like, okay, so I have to remember how to do number of islands, which I've done before on this channel, but I have to just kind of remind myself. So we're essentially going to say, like, okay, for m comma n is equal to length of grid of 0, right? Okay, we can just do something like this. For I in range, length of grid 2 here, actually. J in range, length of grid 1, grid 2 of I. Right, so we're going to say, first of all, if grid 2 of I, okay, also, are these strings or numbers? So are they, okay, they're actual numbers, right? So yeah, these are lists of ints. So in a problem like number of island, these are strings. Okay, so let's go on with this idea. I think this will make sense. So first of all, we're going to go through all of grid 2, and we're going to populate any, we're essentially going to say, like, hey, we can either use a visited set or we can modify grid 2, right? Modifying grid 2 would make things very simple. Also, we have to think about the case, like, what if there's a cell that is shared by, like, what if all of grid 1 is just ones, right? Where it's like you might use the same one multiple times. Or should something like that never happen, right? Because it's like when you populate an island, it'll be so the ones will be specifically for that island. Okay, so we don't have to think about an edge case like that. I was thinking about, like, what if we find 2 islands in grid 2 that share the same one in grid 1, but by nature of, if that happened, then that means they must be part of the same island, right, kind of thing. So we don't have to worry about that. Okay, if grid 2 of I is equal to 0, so this is, you know what, we'll make our life easy here. We'll say water comma land is equal to 0 comma 1, right? So that way it's like, if this is equal to water, right? Then we're going to continue. We don't care. Otherwise, we just hit on that land. We just hit on the land. So here we're going to say num sub-islands is equal to 0. We want to populate. We can also keep track of num islands, right? So that, like, we can use this for debugging. So let's just say, for debugging purposes, remove later. right? So, okay. So like first I want to make sure that like if anything we populate the number of islands correctly, right? So we can do something like this. Is sub-island, we're going to initialize this to true, right? And then it's like at any point, if we find anything that makes it not a sub-island, we set that value to false. And at the very end, once we've done populating the island, right, or like counting the island and setting it all like inside a visited list or whatever, then what we can say is, okay, if it's still true that is sub-island is true, then we've just found a sub-island, right? So, okay, this should not be too bad at all. So we want to populate the island by adding all ones adjacent to the one we hit. Actually, we can keep track. So either we modify the elements of grid 2, or we keep things in a visited set, right? The nice thing about modifying grid 2 is that, well, since we don't need to return it, we can just modify grid 2 in place, right? By converting all land cells we see connected to this land slot into water slots. Note that we could also achieve this by populating a visited set, but doing so this way allows us to reutilize memory in place. Although memory is not really a concern, right? You're just using extra O of squared memory or extra O of mn memory in this case for the visited array, or in the case where every single thing is a 1. But yeah, that's fine. So is sub-island is equal to true. Actually, you know what? No, let's use a visit set, right? Def underscore init self.visited is equal to set visited visited land slots in grid 2, right? We can do self.grid2 to none, grid 1 is equal to none. Or, okay, instead of calling a helper here, or okay, we don't have to use a visited set. Okay, I just have to make a decision whether we use a visited set or not. It doesn't matter. Okay, if we don't use one, then the very first thing we can do here is self.grid1 comma self.grid2 is equal to grid1 comma grid2, right? And now we can just use the self.grid2 for now on. So we do self. So we want to visit, okay, we're going to convert, okay, so directions is equal to, so we can either go up, left, down, or right? So this will be -1, 0, 1, comma 0, 0, comma -1, goodness, 0, comma 1, right? Something like that. Maybe it's more clear if I put this over here instead. There we go. So -1, yeah, so up. Yeah, so up, right, left, down, you understand. Okay. Directions. For direction in directions. For dx, dy, right? So dx means like delta x, so like change in x. So dx, dy in directions. If I plus dx comma, actually we're gonna say pos is equal to I plus dx, j plus dy. Actually, maybe better names for this would be di and dj, right? So I plus di, j plus dj here. If pos self dot m equals none, self dot n equals none, and m is the number of rows. So self dot m comma self dot n equals length of grid 2 of and length of self dot grid 2 0. So this is self dot m, self dot n. Okay, and right, these are the same in length, right? Yeah. Okay, very cool, very cool. If pos if less than or equal to x is less than self dot m and 0 less than or equal to y less than self dot n. Here we're going to need a bunch of conditions, right? So if this and something else and blah blah blah, and okay, so for these and so on, and obviously self dot grid 2 of this guy okay, and it's not been visited, right? So if we modify grid 2 in place, then we don't have to check. Otherwise we do like and x comma y not in self dot visited. For now we can keep track of something like self dot visited, but for now why not just modify things in place, right? So we'll say self dot grid of ij is equal to 0. We'll update it here. And here we'll say x is equal to new I and y is equal to new j. Oh, that did not work the way I wanted it to. Okay, oh well. X like this is equal to new I, y like this is equal to new j. Okay, then the very first thing we're going to do, okay, so so essentially we just hit a 1, right? So if we hit a okay, is equal to water, right? So water and land is just 0 and 1. So if we hit a water and so on, then we continue. Otherwise here we just hit on a land, right? So assert that self dot grid of I j is equal to land, right? So now we're gonna say, first of all, is sub by land, we default this to true. Default value can change. Then we're gonna set this to be a water cell now, right? The idea is that like instead of keeping track inside of a visited array, for now, why not just change? Sorry, why not just change the values to be water slots themselves so that we don't revisit them later and so on instead of just checking self dot visited. But otherwise, I think that's usually like bad practice. So I can change it to a visited set. For now, it's like I don't want to like spend forever just making a decision like, oh, do I use a visit set or not? Blah blah blah. Let's just focus on solving the problem first, and then if I want to do a visit set, then I totally can. So for now, yeah, let's just focus on the crux of this problem. So here we're gonna say self.grid2 of new I, new j. We're gonna set this to be a water cell, right? So this is if it's equal to land. Now we're gonna set this to be a water cell. I is gonna be 0 and so on. So I just conveniently named water and land to be 0 and 1, just so that it's like a bit more readable here. So we set this to water. If self dot so first of all, okay, I have to be careful here. Self.grid2 here, grid2. I have to be careful that I'm doing things correctly. So here, every time I change a land cell to a water cell, right, I'm essentially populating an island. Inside of this island, like, there's going to be ones inside of grid 2, right? So it's like here in this grid 2 island, for example, it's like, let's take these red ones and so on. We're going to be populating all these ones and changing them into water cells, right? So that we never visit them again once we populate this quote-unquote island. Every single one that we're going to visit in through here, what we're going to check is like, okay, starting with this one, is there a one here and so on? There is, okay, no problem, we don't do anything, right? We initialize is sub-island to true and so on. And we're going to keep doing this with every single one. And then this, all of the ones here and here, so I'm guessing this is a valid sub-island, right? So what does this return? Like 3? Yeah, so there's an island here, and island here, right? But for something like this, right, where it's like, okay, this one we see, oh, it's over here, so that's as good. And then we populate this, oh my goodness. This is not a sub-island, right? Because this is a 0 cell, so it cannot be a sub-island, but it is still a full island, so I will delete everything that is inside of this island, right? So num islands, I will always add 1 every single time. But some islands I will only add 1 if this thing is still true. And whenever I see a cell here in this island that is not a land cell over in the grid 1, then I will set this to false, right? So here, for example, if self grid of ij is equal to a water, then is sub island is equal to false, right? But we still need to populate the full island. We just need to like get rid of it, right? So so if self.grid of 2, so this, if self.grid 1 now of new I, new j is equal to water, then is sub island is equal to false, right? Otherwise we set it to water. And so yeah, we want to keep doing this recursively, right? So okay, I need to think about how to do this. Maybe we self.count island. Okay, so let's think about this. Maybe we have a stack here. Why am I forgetting how to do number of islands, right? Essentially, you just want to do like a DFS search here, right? So for DI, DJ in directions, new I, new J. Yeah, so this is cool, but I'm only doing 4 here, right? Okay, so you know what? We're going to have a helper here. Let's just make a helper. Def populate islands. We're going to say self. And we're going to take an I, comma j. First of all, we're going to say self.assert or assert self.grid2 of I, j. First of all, I don't ever need, no, I do need grid 1. That's fine. Self is equal to a land, right? So only call this if it's a land. Updates, populates an island starting from position I, comma j in grid 2, which must be a land cell. Must be a land cell. By replacing, here we're going to say self.subIslands is equal to 0, self.numIslands is equal to 0, right? Self.populate islands is sub island is equal to true, then we're going to essentially say this, right? We're going to say self.grid2 of I and j is equal to true, is equal to water. Instead of visited set, change land cells to water directly. Okay. Okay, so we change this to water. Here we're going to say is sub island. All right, and this is passing as true. Okay. Okay, so self.grid 2ij here is equal to water. If self.grid1 of ij is equal to water, then we know this is no longer a sub-island, right? Is sub-island is equal to false. Then we're going to say, okay, we want to populate. So we can keep this directions logic. And now we're going to say recursively update neighbors that are also land cells, right? So that's essentially the idea. So is sub-island starts off as true the very first call, and I'm going to pass it inside of every call, and at some point it might be false. Directions equal to this for di, daj, and directions. No, yeah. So I populate new j. I check if they're in bounds. I check if it's a land cell, and if it is, I will call this recursively, right? Instead of saying it's equal to water and making this check, I will say self.populate island with new I, comma new j, and this is sub island, which I might have set to false, right? Or maybe I have self dot this is very janky, but is sub island is equal to true at the very beginning here. It's like this thing might mutate it. Or otherwise I don't have to keep track of this, right? So it's like return self dot is return is sub island. Sub island is equal to this, right? Otherwise, yeah, it's just easier if I do this. Is sub island here is equal to true. To use this function, you must first set is sub island. Self dot is sub island. Okay. Let's just think about this. So maybe this works. Otherwise, I'll just use the field because we know that will work for sure. Otherwise, the idea is essentially this, right? So I can get rid of this. Self dot. Otherwise, self dot populate island, right? With I comma j. And also continue. Return num sub islands. Num sub islands plus or equal this value. num islands plus or equal to 1. Here we're going to say print f string num islands equals num sub islands equals. Okay, so we might need to debug. I mean, this might also work already off the bat, but otherwise we can start debugging. Yep. I might also complain about this stuff, right? Yeah. Okay, so okay, now that's all comments. Oh yeah, lol. That happened when we were copy pasting codes. Okay, here we're gonna do the same thing. Land, comma water. So water, comma land actually. Water, comma land is equal to 0, comma 1. Grid 2 of ij here. Oh, okay. Okay, well that works. So yeah, so here we count that there's 1, 2, 3, 4, 5 islands, but only 3 sub-islands. Here we say there should be 1, 2, 3 islands, but I guess only 2 sub-islands, so let's see that. Yeah, 3 islands, no, 2 sub-islands, okay. I mean, okay, let's run this, but otherwise that's literally it. Okay. Are we too slow? No, okay, okay, there we go. GG. Okay, that was a very simple LeetCode problem. Okay, very nice. Okay, as usual, we can always just, okay, well, first of all, very nice. But as usual, we can just clean up our LeetCode solution here. Otherwise, this problem is essentially just number of islands just with like one mini twist on top of it, right? So, okay. I get it's actually no. Let's not use a visited set. So a visited set is cleaner in the sense that like, okay, I will not modify the elements inside of grid 2, right? Which is cleaner in the sense that like, okay, like usually you don't want to like modify an input and so on, da da da. So it's nicer in that way, but also you're using an extra up to O of mn space because, but why, right? So you don't need grid 2 anymore and so on. You only need to return the number of sub islands. So it's just like, why not just use the memory in place that's already given to you, right? So don't need a visit set and so on. Self.grid1, did I ever use that? Yes, in populate islands. So yeah, so that's important. So I need those. We can put this as a none and none because these come together. Self.m, self.n is equal to none, comma none because those go together. Self.subislands, we don't need that, right? Self.subislands. What about num islands? Yep, we don't need that. We definitely don't need this, right? So we only need to initialize these values here. Okay, let me drink some water. Oh. And here, you know what? We're going to change water with self.water. Okay, it's fine. Yeah. It's just weird. It looks weird to have constants like this, but why not? So let's get rid of this, but yeah. Land with self.land. No, it just looks way weirder for no reason. Let's just keep it like that, even though we have it in 2 functions. That's totally fine, right? So water comma land is equal to 0, 1. We initialize self.grid 0 and 1 like this. Okay, so initialize those values. That's fine. Water comma land is equal to that. We actually don't need num islands, right? So we definitely don't need that. Num sub islands. Can actually simplify this. So if this is equal to land num sub islands plus or equal self.populate island ij, right? and then just return the number of sub-islands that we found, right? So first of all, this returns a Boolean value, and so it's like usually if you in Python, if you do plus or equal true, it'll actually be like plus or equal 1, and if you do plus or equal false, it'll be plus or equal 0. So I'm kind of abusing Python semantics right over there, but that's essentially why like this returns a bool, but I'm plus or equal adding it. So that's fine. We can discard these comments here. Self-grid. Okay. Def populate island, water 0, 1. Assert that, yeah, we're in a land cell. Instead of using a visit set, change lead cells into update lands to water cells directly. Land into water cells directly. So yeah, so update this into water, and then if self.grid of I, so okay, yep, okay. I'll explain in just 1 second for DI. Yeah, so this is good. We definitely don't need that anymore. Okay, so yeah, so this thing starts off as true, right? Is sub-island. This starts off as true, so instead of that, we'll just enforce, but that's essentially the idea, right? Is sub-island defaulted to true, and value set to false if any corresponding cell inside grid 2 island happens to be a water, i.e. non-land cell. So that's essentially the idea. Then okay, we do this and this, we can delete these 2 lines of code, and okay, and therefore we have a clean, very working solution that I can now beautifully explain. Okay, let's wait for it to load. But otherwise, there we go. 66%, we're in here and so on. So the solution, very much nice, perfecto, nothing more to add. So, okay, this problem is not too tricky. So if you've solved the problem number of islands before, this problem will be very, very, very trivial, right? So if you haven't solved number of islands, I would recommend solving that problem first before you tackle this problem, although they're very, very similar problems. So the idea with number of islands is that you essentially want to count the number of islands, right? Which is what I had done before, where it's like, instead of having a conditions where like an island might be a sub-island, I'm just counting normal islands. And so the way we did it is, if I take a grid here, like grid 2, I'm going to loop through every single possible index that is in here, right? So well, how about we represent this grid like it is here. So 1, 2, 3, 4, 5. So here we have 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0. Okay, there we go. Okay, so we essentially have this grid 2 here, right? And so here's how the algorithm works. So if you want to count islands, right, the way you're going to do it is you're going to loop through every single possible index inside of grid 2, right? And so what we're going to do is every single index that we visit, every single position, where a position is like, you know, an ij pair, whereas like I is between 0 and the number of rows, and j is in between 0 and the number of columns, then we're going to say, okay, if it is a water cell, i.e. it's a 0, then we're going to skip it, right? Ignore this. Otherwise, if it is a land cell, we're going to essentially populate this island by setting every single connected one inside of that island into water cells, right? And then once we're done with that, we can say, hey, we have just found 1 island, so add 1 to the total number of islands we found, right? And so that's classical number of islands. And the difference with this one is that when I populate the island, what I'm going to do is for every single one that I see in here, I want to make sure, okay, I better see that the corresponding same position in grid 1 is also a 1, right? That way it has to be a sub-island, right? If every single one in an island that I find is also a 1 in this grid 1, then the grid 2 island must be a sub-island of grid 1. Otherwise, if it's an island like this one, where it's like even one cell happens to be a water cell in grid 1, it is not a sub-island, right? So that's the only modification I really make to the number of islands problem. But okay, otherwise we can kind of look at an example of how this works. So I told you, I start from 0, 0, and I'm going to loop through every single index, right? So the very first one is a non-water cell, which means I'm not going to skip it immediately, right? So what I'm going to do is like, okay, we are at a 1 here, right? So I'm going to populate the island. So now we're inside of a populate island call, right? And so from here, the very first thing I'm going to do is like, okay, is sub island, it's going to be set to true, right? At the very beginning, and my ij is equal to 0, 0, right? So I start from this very position, right? And essentially what I'm saying here is like, okay, at first we're going to default is sub island to true, right? Until I am proven wrong, I'm just going to claim that this is a sub island, right? Until I find that an island cell in here happens to be a water cell instead of grid 1, which would make it a non-sub island, I will only set it to false if I ever see that. But otherwise, for now, for the time being, I haven't been disproved that this is not a sub-island, so we'll keep it as true, right? So initialize to true. So here, the very first thing we're going to do is, okay, we're going to set this to a water cell, right? But first, we're going to say, okay, this one here, we need to check. Is it also a 1 inside of self.grid1, right? And here it is, right? So if it wasn't, that means that like this 1 inside of this island, which we haven't yet populated so far, is not a sub-island because we know that this is a water cell and therefore it's like this cannot be a sub-island of grid 1, right? But in this case, this one is inside, is also a 1 in self.grid 1 at the same position. So we don't do anything to a sub-island, right? So otherwise we set this to 0 and then we look for the neighbors up, down, left, right. We can't go up, we can't go left because that's out of bounds. So here I say like, okay, so for up, left, down, right, and so on, those are my directions. If the new position is in bounds, and it's a land cell, then I do some work, right? So in this case, up and to the left of me, there is nothing, right? So the only ways I can go is either down or to the right. If I come down here, not very interesting, it's a 0, so I ignore it, right? So like this condition inside my if statement will fail and I won't do any work. So, but otherwise this one is a 1, right? So I continue from then onwards. And then I just repeat the process, right? So now I and j's, this is gonna be like 0, 1. And so from here, I'm gonna say, okay, is it a land cell inside of self.grid 1? Okay, so I'm in this position. Let's see. Okay, it is. So I'm not going to change is sub-island. But now I'm going to set this to a water cell, right? So set it to a water cell. And now let's look at the neighbors, right? So 0. Okay, this is a 0. Don't need to touch it. This is a 0. Don't need to touch it. I can't go upwards. Oh, but I can go rightwards and it's a 1. Okay, so same thing from here. This position, 0, 2. Okay, I'm at this position. Is the same position over in self.grid 101 as well? It is. That means, okay, so far, I'm convinced this might still be a sub-island, right? So I don't change my sub-island value, and I'm just going to carry on. I'm going to set this to a 0. I'm going to look up. I can't go up, so I'm not going to look up. So left is a 0, so I ignore that. This right is a 0, so I ignore that. Oh, below me is a 1, right? Okay, so from this one, okay, also I'm going to keep this at 0, 0 for now, but that'll make sense later because, again, we started this whole iteration from the very first element here. But otherwise, we're at this 1 here, right? And so same thing again. We're at this position 1. We're going to look inside of self.grid 1. Okay, this is also a 1, so I don't touch my is sub-island value yet, right? So this is still true. And then, again, I carry on. Set this to 0, look above. This is a 0. Look to the left. This is a 0. Look down. This is a 0. Oh, okay. I look to the right. This is a 1. Let's carry on. I'm at this position. Okay, the same position in self.grid 1 is a 1 as well. I do not touch is sub-island. I do not set it to false, so I keep it as is. I set this to 0, and again, same process. Above me is a 0, so don't do anything. Left is a 0, right below is a 0. Oh, but to the right is a 1. Okay, is this same position here in self.grid 101? Yes, it is, so I don't touch my is sub-island value. And then I set this to 0. Above me is a 0. To the left of me is a 0. Below me is a 0. To the right, I can't go, so I stop my execution context here. And I return is sub-island, which we know is still true, right? So we have populated essentially this island. We've actually set its full values inside of self.grid 2 to 0. So now these are now water cells, right? That's why I kind of wanted to draw my own example over here. But we're going to return is sub-island. And so here, when we have finally populated this this island over here, this is going to return true. And we know that true is going to be converted into 1 by Python. So num sub-islands were plus or equal 1, okay? So far, the number of sub-islands we found is 1. Right, so let's keep track of this. Num sub islands is now equal to 1, right? So, okay, now let's keep on carrying on. The reason I said I'm going to keep ij in 0 is because I went on from this computation, right? And then I just populated the island because that was a 1. Now I am done with that. So again, but the initial algorithm loop is I'm going to loop through every single index, right? Every single ij until the very end. So here, I'm at the 0, it was at 1, and I populated the island, so I'm done with my work now. So I go to the next one. Oh, this is a water cell. I skip. Next, okay, water. I skip. 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 This is, okay, this is water. I skip. 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 Go on to the next one. Water. I skip. Oh, a land cell. All of a sudden, I do not skip, right? So here we're going to repeat this very same process. We're going to set is sub island to true as of my default value. My I is now equal to 2. My j is equal to 1. Actually, yeah, 1. So this is position 2, 1. And now I'm like, okay, I need to populate the island from here. So same rodeo, we set is sub island to true. And we're going to say, okay, from here, we're first going to check, okay, this position, is it a 1 as well instead of self.grid 1? And let's check. So we're at this position here. And oh my goodness, no, it is a water cell. So now all of a sudden, is sub island is equal to false, right? And one thing that's important is I do not stop the computation here, right? Just because I found that this is not a sub-island and so on, I'm still going to completely eradicate the island from the problem, right? And convert all that island's land cells into water cells so that they don't have to be looked at over again and make some correct computation later. I'm just going to populate the full island. It's just that when I return from the function, is sub-island will be false, and this will not be a sub-island, right? This is an island, but it's just not a sub-island, right? Because we have found at least one cell that is a land cell in this island. Okay, this happens to also be a one-element island, but even if it wasn't, the same holds. It is not a land cell here corresponding in self.grade 1. So this cannot be a sub-island, no matter how large or how small from grid 2 inside of grid 1, right? So now we have set is sub-island to false. And again, same rodeo, we set this to a 0, and then we look at our neighbors up, down, below, and left, right? So up is a 0, to the left is a 0, below us is a 0, so to the right of us is a 0. So actually we're done. Again, this is just a one element island and so on. So, but there's no more work to do from there. So we stop and then we return, and then so we add to num islands whatever we return. But of course, sorry, I have quite a bit of shortness of breath today, but so forgive me about that, but otherwise we return false here. So plus or equal false is going to be plus or equal to 0 in Python. We essentially don't update sub-islands, right? So this stays as 1, which is good because this was not a sub-island. Then we were from here. Now we're done with this element, right? It used to be a land cell. We changed it to a water cell, and we populated the island of any single land cell that touches this one, right? So now we carry on. So from here, we come here, this is water, so skip, this is a water, so skip, this is a water, so skip, come here, okay, this is a land cell, so do not skip it, right? So we're gonna play the same game. So here, what we're gonna say is, okay, same rodeo, you know what, we're gonna set this back to true here, so we haven't been proven wrong, this might still be a sub-island, and we're gonna say, okay, this one here, same story. The first thing we're going to check every single time, the very first thing we check is, okay, we take this position. Is it also a 1 instead of self.grade 1? It is. Okay, I have no reason to be convinced yet that this is not a sub-island, so I will keep it as true, right? I do not update its value to false. I'm going to set this value to 0, and now I'm going to check all the neighbors. So let's look. I can't go to the left of me because that's out of bounds. Above me is a 0, so that's water. To the right of me is water. Below me is water. Okay, I'm actually done. So I've actually populated the full island, quote unquote, here, and so I'm going to return the result, and the result here is true, right? And so you see this red, this is good because this is actually a sub-island. So here inside of num sub-islands, I'm going to plus or equal true, which again gets converted into plus or equal 1. So I update this to 1 plus 1 is equal to 2, right? And so again, and then we continue from there. So now we're done with this index, again, in the main loop with the double for loop here. And so we're going to say, okay, we've populated the island. This used to be a land cell. We changed it. Let's carry on, right? So here, this was a water cell. Now we go on. This is a water cell, so skip it. Okay, now we're back to a land cell, right? Same rodeo. Okay, first thing we do, this position, is it a land cell over in the self.grid 1? It is not, right? So all of a sudden, we already know, okay, is sub-island, this is going to be the false. Remember, we're still going to populate the island and set all of the islands 1s to 0s inside of self.grid 2, as if we were trying to count the number of islands. But we know that when we return, we will not consider this a sub-island, right? So otherwise we carry on. So we know we set sub-island to false because, again, this 1 is not a 1 in self.grid at the same position. So in self.grid 1, sorry. But otherwise we continue onward. So we set this to a water cell. We check above us, this is water. Here, this is water. Here, this is water. Oh, but to the right of us is a land cell. So from then, we do the same check. Again, it's kind of useless to do the check when we already know it's false, but again, that's just the algorithm. It's just O of 1 to check anyways. So again, We take this, we check, it also happens to be a water cell again, so we set from false to false, doesn't matter, it's already false, you're just setting it to false and so on. You already know it's not a sub-island, so resetting a false value to false does nothing. So you you set sub-island to false again, and otherwise you set this to a 0, and same spiel, you go above, you go left, you see that these are all zeros, and then below you is a 1. So again, you continue from then onwards. And so from this one, you're going to say, okay, is this one a 1 as well in self.grid 1? It is, okay. So I don't change whatever the value of is sub-island, which might have been true, might have been false, but the point is I don't change it, but it's already false because we already saw two that made this not a sub-island. But otherwise, we make the 0 and same spiel. We go up, we see this is water, this is water, this is water. Below us, we can't go because it's out of range. So we are done with this computation right here, right? So then we're going to return. If this is a sub-island, this is false, so we're going to plus or equal 0 to num sub-island, so we're actually not going to change this, and so on. And then this is going to be reset back to true for the next computation. So then, okay, we just finished this. This used to be a land cell right here, and now we are done with it. And so we're going to keep iterating. Okay, this is a water cell, this is a water cell, so skip, skip, skip. This is a water cell, so skip, and then this is a land cell, okay? Now, same rodeo. We're going to say, okay, for this land cell, is it also a land cell in self.grid 1? So, okay, we're at this position. Let's look over here, and yes, it is. Okay, so we have is sub-island is set to true. We are not going to change it. And again, same rodeo. We're going to set this to a water cell. We're going to look above us. This is a water cell, so ignore. This is water cell, so ignore. This is water cell, so ignore. Below us, we can't go. So we're actually done with populating the island. This also happens to be a 1-element island. And so then we're going to return this sub-island, which we know is true. We're going to come in here where num sub-islands plus or equal to this true value. Again, plus or equal true gets converted to a 1 in Python, where false gets converted to 0. So this becomes 2 plus 1 is equal to 3. And then we carry onwards from there. So we have finished the land cell from this position. So we're going to carry on. So from here, we're going to check this cell. This is a water, so skip. This is a water, so skip. This is a water, so skip. And finally, we are done with the whole double for loop, right? And from here on, what we do is return num sub islands, right? So as soon as we're done with this double for loop, we're going to return num sub islands, which in this case we saw is equal to 3, which is exactly the result that we wanted to return. So that's exactly how this algorithm works. And again, what I meant by using a visited set earlier is like, so some islands like here, like, you know, that used to be 1, 1, 1, 1, 1, 1. Essentially what I do is instead of setting these to zeros, I would essentially just mark their position inside of a visited set, and instead of checking if something is a water cell or a land cell only, I would also just check like, okay, if it's a land cell but it's not been visited, right? So it's not been put in self.visited, then I can consider it as a new one inside of my island, right? But I think it's just a cleaner solution since we don't need to not modify grid 2 to just modify grid 2 and set everything to water and kind of use that for our results anyway. So it forces us to not use an extra O of n memory for no reason, right? So we're just reusing the memory that was already given to us. So it's just nice for that convenient reason, right? But otherwise, yeah, that's pretty much it. I hope that explanation kind of makes a lot of sense. Again, if you've not solved the problem number of islands, I would highly recommend solving that one first because, again, it's essentially this problem just a little easier. Where it's like instead of counting sub islands, where it's like you have to, every single island you populate, you have to check, okay, is this a sub-island or is it not? You just count the number of islands and so on and then return that value. And then doing this problem after doing the number of islands problem will be very, 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 very trivial. And so yeah, otherwise that's pretty much it for my explanation. Yeah, okay, that's pretty much it for my explanation. So I hope that made sense. By the way, sorry, I really have shortness of breath today. I hope you may forgive me for that. I know it's not the most fun when you hear a guy with a raspy voice talk for several dozens of minutes, but I hope you were able to hang on with me there for this video. But otherwise, if you want to do something similar to what I do, the extension that I use is called LeetSync. I plug this always inside of all my videos. I'm not sponsored by them. I did not make this extension and so on. And just because I use this extension by no means means that you should trust this extension yourself. Always doing your own due diligence before you trust a random guy on the internet, but I always just want to show this because it's like, this is the setup I use, and in case you want to do something similar to what I do, might as well show you the way that I do things. So essentially what this extension does is whenever I submit the problem here on LeetCode, and it gets accepted here with the submit button, it will automatically push my solution to my GitHub repository. So if I come into my GitHub repository and I come into LeetCode here, and the problem was called count sub islands. You'll see that it says, okay, there was a submission just now, even though I was not on GitHub just now. And you'll see that 23 minutes ago, the very first time I submitted this problem correctly, it posted a copy of the README, as well as every time I submit a correct solution, the most recent solution that I just submitted, and my updated code in there. So that's essentially how that extension works. Super, super useful in case you want to do something similar to what I do and track your LeetCode problems on your GitHub repository, especially if it's for a reason like mine, where it's like you want to have like 1 year's worth of green contributions here on GitHub and you know, just populate it, or if you want to have it a reference for yourself or for others to see, whatever the reason may be. I always figure that in my videos, I might as well plug the way that I do things in case you want to do something similar. But of course, just because I use this setup and so on, and I trust these extensions and so on, again, just always do your own due diligence before you like copy some random guy on the internet setup and maybe get yourself in trouble. Like I hope not, but like again, I just always want to give like a fair warning before I give advice on anything to anybody. But otherwise, yeah, that's pretty much it for today's video. So I hope you did find it useful or enjoyable. If you did, I would highly appreciate it if you left a like or a comment. If you do leave a comment, as I say in all of my videos, I promise to respond to every single comment that's left on my channel. So whether you want to give advice on my videos or the other way around, or just have a conversation or tell me what inspires you to do LeetCode, I would be more than lovely for me to hear what you guys have to say. And I love chatting with you guys and so on. A couple of you have already been leaving comments on my channel. I love having the one-on-ones with you guys. So if you're new to this channel, or you've been like watching for a little bit and you want to like have a talk with me or lay some feedback, just feel more than welcome to use the comment section as an opportunity to do so, because I genuinely love talking with you guys, and whenever one of you guys leave a comment, it always like puts a smile on my face, and I love replying to them. So yeah, if you're hesitant to leave a comment, please feel like don't be, and just leave one and so on. And I love talking with you guys. So even if it's just to have a conversation about whatever you want to have a conversation about, I would be more than happy to do so. And yeah, otherwise, that's pretty much it for today's video. I hope it was useful, and otherwise, I'll just catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.